test. Let me make sure we all know when that's going to be. Topic 7 test will be March 2nd, next Tuesday. You have actually already learned almost everything that's going to be on the test. The only new information you'll be learning is tomorrow, and then from then on, we're reviewing. So topic 7 test is on Tuesday, and it's going to cover all exponents. So the rules for exponent, multiplying exponents, adding exponents, dividing exponents, rewriting exponents as radicals, all of that. So that's one thing. Rational and irrational numbers and what happens when you add them, when you subtract them, when you multiply them. And then finally, what we've been learning and what we're going to be reviewing today, which is exponential functions. So exponents, rational and irrational numbers, and exponential functions. That's all going to be on the test on next Tuesday and also Wednesday. Remember, it's always 2 days. So March 2nd and 3rd. So that is announcement number 1. Announcement number 2 is that let me actually pull it up so that I know that I'm giving you accurate information. But this morning when I was looking at the completion rate for the quiz that was due on Friday, I was pretty disappointed with this period. Period 1 or period 2 did a little bit better, but period 8 out of 34 students that I have listed in period 8, let me see how many actually completed it. 15 out of 34. 15 out of 34. I just want that to sink in. Less than half of you completed your quiz. Why? That doesn't make any sense to me. It doesn't make any sense. And the part that really gets me is that the people who did it are the people who already have pretty good grades in my class already. I mean, that's not entirely everybody, not entirely true. But for the most part, the people who did it are the people who are already doing well. So the people who didn't do it are just making life worse for themselves because you just earned a free F in the gradebook.
Do the people who did it get extra credit raise?
No. You don't get extra credit for doing the work you're already expected to do. That's not how life works. That's not how my class works. So to be completely honest, I'm very disappointed in that. And for that reason, I will not be accepting any late turn-ins on that quiz because we are about to go over the answers. So it would be unfair if people turned it in late after the answers were already revealed. So if you didn't do it, you're out of luck. There is no backup plan. That is a free F, free F that you just gave yourself in the gradebook. And that's what happens. That's what happens when y'all, and I tried my best. I said, listen, if you can't get it in on time, let me know. And did anybody let me know? I had one person tell me, and that person knows who they are, but that was it. Nobody else said a single word. So guess what? All of you who didn't do it and didn't say anything, F. Straight up. Matter of fact, I might even count it twice because that's how angry I am. And I really just don't understand at this point. I really don't understand. Why? It makes no sense to me. It makes absolutely no sense. Like if I'm failing a class, why would I do less work? Like if I'm literally getting an F in a class, why would I just skip my work and not do it? It makes no sense to me. And you're getting to the point now where a lot of you guys who have been continuing to get Fs, like it's getting too late. At a certain point, you're not going to be able to bring that grade up. Because we're already more than halfway through the marking period. So if you want to improve that score, like time is running out and you are not doing enough. And I know I always get all these messages on the day before the report card is grades are due saying, Miss Lopez, what can I do for extra credit? Like, that is insulting at that point. You're asking for extra credit the week that grades are due when you have 7 or 8 assignments left completely undone. Nah, no, that's not how life works. No. So congrats on your free Fs, those of you who earned them. Everybody who did do the quiz, I appreciate you. And I don't even need to say it because you guys are the ones who are always consistently doing your work. And you already know that I appreciate you. But this week, probably I think on Wednesday, but I'll let you know tomorrow. I believe it's going to be on Wednesday. I'm going to have an after school meeting with myself, Mr. St. Rose, Miss Dariskar, and you and your parents and guardians. It's not for everybody. This meeting is for those students who are not doing the work and not getting the grades that they should be getting in order to pass this class. So if you're getting A's, B's, even C's, you're probably fine. I'm talking about those students with D's and F's in the grade book. We will be having a parent guardian meeting probably on Wednesday of this week on Zoom with me, Mr. St. Rose, and Miss Dariskar. Because if y'all don't want to listen to me, then I'm going to make sure you listen to your assistant principal. Because it's getting to a point where like I really just don't know what else to do. I really do not. So so that is what that is. Look forward to that meeting. I'm sure it'll be lots of fun. And let's go ahead and get started with this bell ringer. So this bell ringer, like I just mentioned, this is from the quiz. I am going over the quiz answers. So that quiz is no longer available to complete if you haven't done it yet. Let's go ahead and get started. So some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 5,000 equals 0. Times 0.98 to the power of x represents the value, y, of one account that was left inactive for a period of x years. What is the y-intercept of this equation and what does it represent? So let's begin with which of those numbers is the y-intercept? Is it the 5,000 or the 0.98? Or
0.98.
5,000.
Ooh, okay, I got two competing answers. 5,000 or 0.98? Which one is the y-intercept?
5,000.
Now let's think about what the y-intercept represents. In a real world problem, what does the y-intercept represent?
The amount at the start.
The starting value, good. Now, if you wrote down your notes in your notebook like you're supposed to be doing, then you can flip back a couple of pages and you should see this somewhere in there. What is this equation called? You wrote it down.
Exponential decay.
Good. This is exponential decay. This is my exponential decay function. Now, every part of that equation means something different. So we labeled it. And when we did so, what did A represent?
Y-intercept.
The A is the y-intercept, which is your starting amount. What's the R represent?
The rate of growth or decay.
Or decay, good. So this is the percent. In this case, since it's a decay function, we have percent of decay. But what do we always have to do to that number? To that percentage?
Subtract for 1.
We subtract it from 1.
We turn to a decimal.
We turn it into a decimal. So the percentage becomes a decimal. What does the T represent?
The T represents time.
Time, good. Time. So every part of that equation means something different. And in our equation, I highlighted those two numbers. Which one, I'm going to ask again, which one is the y-intercept?
5,000.
5,000. So A and B are automatically out. And then we know that the definition of the y-intercept, no matter what type of function I'm talking about, can be linear, exponential, quadratic, logarithmic, sine, cosine. There's so many different types of functions you guys don't even know about. No matter
Absolute
what
value.
type of, absolute value, there's so many. No matter what type of function I'm talking about, the y-intercept is always going to represent the starting amount. Not the amount after 10 years, not the amount after X years, not the amount after 30,000 years. No, it's the starting amount. So C is the only answer that says that correctly. Do I have any questions on how to write that equation or what each of those numbers is representing? Okay. Well, part B, I'm looking for the percent of decay. And this is where I told you guys on Friday, and I'll say it again, you have to be very careful. Does the equation tell me right off the bat, does it actually give me the rate of decay, or do I have to do a little bit of math?
Math.
Just a little bit of math. Because that 98 is not the rate of decay. That's what's left over after I take away the percent of decay. Because remember, originally in those parentheses, you've got 1 minus r. So let me rewrite this equation. Okay, that's the equation that they gave me, but we know that originally this used to look like this. 5,000, parentheses, 1 minus something to the power of x. So your job is to figure out what was taken from 1 in order to give you 0.98. So what is that answer? What is the number that's taken from 1 in order to get 0.98? Good. 0.2. That is your percent decay, but you got to turn that into, 0.02. That is your percent decay, but you got to turn it into a percentage. So now, okay, 0.02 as a percentage is
2%.
2%. 2%. That is my final answer. Okay, the rate or the percent of decay is 2% because that's what was taken from 1 to give you 0.98. Okay, so that's always going to be like this. They're always going to try and trick you with that question. You have to be very careful. Does anybody have any questions on anything that's on this page? Today we are reviewing everything. So now is the time to ask those questions because you will not get that chance again until maybe on Monday. Does anybody have any questions? Okay. I'm going to continue reviewing the quiz. So I am going over all 4 questions, especially because a couple of them were a little bit tricky. And this is the one that most people got wrong. And I think I know why. So let's actually just take a look at it and figure out what we're supposed to do. So the question is asking me, which of these functions is exponential? Which of these functions is exponential? Now, we learned a good strategy for figuring that out. So what are we supposed to do when that is the question? What are we supposed to do in order to figure it out? And you can send it in the chat, you can send it privately. I just want to see what people think. How do I figure out if an equation, if a function is exponential?
Divide.
Okay.
Divide.
Okay. And how am I dividing? There's a specific way.
Bottom up.
Bottom up. That's exactly right. So I'm going to take f of x. I'll start with f of x, and I'm going to divide going backwards from the bottom all the way up to the top. And what I'm going to do is I'm just going to jot down my answers on the side. So you can do this in your notebook. You can do this, on a piece of paper. We're just going to see what we get. And you're going to do this for every single, from the bottom all the way up to the top. Don't do it 3 times and then give up halfway. No, you got to do it all the way, because sometimes they'll trick you. Sometimes it's the same for 3 ways, and then you do it one more time and it's completely different. So you got to be super careful. Now, the other thing is, when you get an answer, I don't want you guys to round. Okay, so just put like 4 decimal places. Put up to 4 decimal places. So starting from the bottom, okay, 212.46 divided by 200.43, I get 1.0600. Okay, and then I'm just going to do the next 2 set of values, and like I said, I'm going to keep it to 4 decimal places. 200.43 divided by 189.09, I get 1.0599. I'll put one more, 997. I think this was a 2. The more decimal spots, the better. And I'll show you why in just a moment. Okay, 189.09 divided by 178.39. I got 1.05998. Okay, then I keep going. 2 more. 178.39 divided by 168.29. I get 1.0600. 001 actually. And then for the last two, 168.29 divided by 158.76, I get 1.06003. Okay. So the reason that I gave it that many decimal spaces is because I just want to make sure that when I round everything, it rounds to the same number. So if I round everything to 3 decimal spots, to the nearest hundredth, that's how far I'm going to go. I'm going to go to this number right here, to the nearest hundredth. Let's go ahead and do that for all of them. If I round to the nearest hundredth, what do I get for the bottom number?
1.06.
Yeah, 060. And I think I said hundredth, I meant thousandth. I'm going to the 3rd decimal spot. So to the nearest thousandth. Okay, how about here? If I'm rounding to the nearest thousandth, does that 9 round up or does it stay? Or what happens?
Up.
Rounds up, right? Because it's got a 9 right next to it. Well, if I'm rounding 9 up, what does it round up to?
1.060.
1.060. Same thing. 59 goes up to 60. How about here? To the nearest thousand.
1.060.
1.060. Same thing here. 1.060. And same thing here. 1.060. So long story short, I got the same exact answer. Once you round it, same numbers. What is that number called? Since I got the same answer each and every time, what is that called? Good, Daniela, good. Cassie said it as well. Good. This is my growth rate. Okay, that is my growth rate. And by the way, if that's my growth rate, what is the percent of growth? That's
106.
in the parentheses.
100%.
This is what would be in the parentheses. I don't know the starting value because they don't tell me, but if that's what's in the parentheses, what's the percent of growth?
106.
Mm-mm.
0.94. 94.
Mm-mm. Okay, so this is where I want to make sure we understand. There's two different things. There's the growth rate and there's the percent of growth. So let's everybody just think about the fact that those are two different things. Those are two different things. Because if I'm asking you for the percentage, I'm asking you, okay, what number was added to 1 to give me 1.06? So I'm asking again, what is the percentage of growth? What number was added to 1 to give me 1.06?
0.6, I guess.
0.06, yeah. So again, one more time, I'm going to ask it, what is the percentage of growth?
0.06.
What is the percentage of growth? There it is.
6%.
6%. This is the percentage, but that's what was added to 1 to give me 1.06. Okay, does that make sense? I just want to make sure we understand the difference. Because one is just the rate, and then the other one's the percent rate. And the percent is the number that was taken from 1 or added to 1. And then, so the language matters. The way that we say things matters. Does anyone have a question on what the difference is?
One thing. So if it has 1, then you just separate it.
Yeah. If it has a 1 in the front, it's a growth function. It's growing, right? So you just think, okay, what number was added to 1? So in this case, it's 0.06. And just like this problem, if it starts with a 0, it's a decay function. So the percentage is whatever number was taken from 1 to give you 0.98. So if it starts with a 0, it's decay. If it starts with a 1, it's growth. So this was a growth function. Okay. And it has a constant rate. So therefore, I know that f of x is exponential. Okay, but now let's take a look at g of x, because maybe they're both exponential, or maybe g of x is not exponential. And if you took the quiz and you got your answer wrong, then you probably know what might be going on here. Okay, g of x, same exact strategy. I'm going to go from the bottom, go up, and I'm going to go to, again, 4 decimal places. You always want to try at least 4 because you just want to make sure that it's rounding to the same number, because sometimes it does, sometimes it doesn't. Okay, from the bottom up, here we go. This is the most annoying part of the process, but you just got to do it. 159.38 divided by 154.64, I get 1.03. But I get 1.0307. I rounded that 6 up to a 7. So 0307. Next one. 154, oops. There we go. 154.64 divided by 149.91. 54.64 divided by 149.91. Okay, I get 1.0316. Okay, keep going. And at this point, you might be saying, okay, Ms. Lopez, we get it. I understand. I know what I'm supposed to do. Yeah, I know you know. This is not hard, but you still got to do it all the way up. 1.0326. Okay, next one. What am I on? This one? Okay. 145.18 divided by 140.44. 1.0338. Okay, last one. Last pair of numbers. 140.44 divided by 135.71. I get 1.0349. Okay, there's all my numbers. They all seem to be pretty close to each other, right? They're all, okay, 1.03 something. So they're all pretty close to each other. But when you round it to the nearest thousandth, let's do that again. To the nearest thousandths place, what do I get for the bottom number? Does the 0 get rounded up, or does the 0 remain as a 0? Do I round up or do I stay? And if you don't know, tell me right now in the chat, say, Ms. Lopez, I have no idea how to do this. Please explain it.
Do I give the answer?
No, if you're not sure how to round that number, let me know now, because I'm happily going to go over it. But if nobody says anything, then I'm going to assume we all know how to do it, and everybody here is just being lazy, and you don't want to reply to me in the chat. Okay, thank you for your honesty for those who have responded. I appreciate that. Quickly, if you already know how to do this, great, but it's always worth explaining one more time. When I say round to the nearest hundredths place, no, actually, let me go back. When I say round to the nearest tenths place, which one's my tenths place?
With a 0.
The first 0, right? Okay, if I'm rounding to the nearest tenths place, that's saying, okay, I'm gonna fill in that blank, and that's the last number I'm gonna write. Well, in order to know what goes in that blank, you look at the next number. What's the rule? Does anyone remember there's a little rhyme?
If it's under 0, it stays the same. If it's over 5, you round up or something.
That doesn't rhyme very nicely, does it? There's a rhyme. 5 or more, raise the score.
4 or below.
4 or less, let it rest. So 5 or more, raise the score. 4 or less, let it rest. Well, I have 1.03. So that's less than 4. So 4 or less, let it rest. I'm going to let this rest as a 0. So if I'm rounding this to the nearest tenths, it's 1.0. What if I'm rounding it to the nearest hundredths? Which one's my hundredths place? Which one's my hundredths place? Good, the 3. Okay, so that means I'm going to write 1.0 and then fill in that blank. Does it stay as a 3 or does it round up to 4?
3.
Stays as a 3 because the number right next to it is a 0. So the 0 makes it rest. It stays as a 3, 1.03. Thousandths place. Which one's my thousandths place? Oops.
The second 0.
The second 0. So if I'm rounding to the nearest thousandths place, that means I'm going, okay, that means I'm going 1.03 and then filling in that blank. Well, what's next to the 0?
7.
It's a 7. 5 or more raise the score. So what does the 0 become?
And
Good, Daniela said it in the chat. A 1. Raise the score. So it goes from being a 0, it bumps it up to a 1. That's basic rounding, y'all. You just look at the number next to it and then decide, am I going to keep it the same or am I going to round it up? That is all. So for my bottom number there, I got 1.031 because I'm rounding it to the nearest thousandths place. So keep testing yourself. Let's see if we understand the next one. What is 1.0316 to the nearest thousandths?
1.032.
1.032. Good. 1.032. Because the 6, I have a 6 right next to the 1. The 6 is going to turn that 1 into a 2. Keep it going. to the nearest thousandths, I get 1.03 what? What goes in that blank? Good, a 3. Because the 2 got rounded up to a 3. How about here? 1.03 what?
4.
4. And then finally, 1.03
5.
5. Do I get the same number in all of these? Or are they slightly off?
They're slightly off.
Slightly off. And it might not seem like a lot. You might say, look, Miss Lopez, they're all 1.03. They're basically all the same. Yeah and no. Yeah, they are really close to each other. You're right. They are very close to each other. But exponential functions, a little tiny bit goes a very long way. It goes a very long way. So since they're not exactly the same, we cannot call this exponential. So this is not exponential. They would have to be literally exactly the same. And that's very important to understand because a lot of people chose answer choice C. And I can see why you might have chosen that because they all are really close to 1.03. But at the end of the day, it's not exponential. Only f of x is exponential.
Miss, how do we check if we're supposed to go to the thousands or the hundreds?
Say that again. How do you check what?
How do you know if you're supposed to go to the thousands or the hundreds?
I would say my rule of thumb is always go for the thousandths place because remember what we said. The percentage for this one was 6% because that's what you get when you move the decimal space over 2 times, right? So if you go to the nearest thousandths place, you have enough numbers to get the percentage. If you go anything less than that, then you're not going to know the percentage. And I know for a fact a lot of people probably got this wrong because even though they did the math correctly, they rounded to the nearest hundredths place instead of writing it to the nearest thousandths place. So I'm letting you know now that on a test, go 4 decimal spaces, even 5 decimal spaces if you feel like it. If you want to do even more, that's even better. The more you do, the better answer you're going to get.
Miss, this math is dumb, stupid.
I know, I'm sorry. I know a lot of people are angry because of this question, and I understand. But this is what it's like on a test, and I want to mimic the test as much as I can. So that's why I put it up. Because even though it's not, it's not the nicest question in the world, but it is very similar to what you might see on a test. So do I have any questions on this one?
On the test, are we gonna be able to use a calculator too?
For this type of question, definitely, yes. Yeah. They won't ask you this unless you have a calculator. Because these numbers are not something that you need to do by hand. That would take way too long. Any other questions? Okay. The most important thing is if you got it wrong because you didn't go far enough, now you know. So you're not going to make the same mistake again going forward, okay? Now you know. That's okay. We learn from our mistakes. Okay. Here's another one. This was number 3 on the quiz. Identify the graph of this function. So we're trying to figure out which of those graphs is corresponding to the equation. And there's a couple of ways to do this. So can anybody tell me one strategy for figuring out which one of these is the correct graph?
Do I put in chat?
Say that again, plug.
Oh, do I put it in chat?
Oh yeah, you can put it in the chat or out loud. Now don't tell, okay, so you can tell me the answer, but I already know what you got because you took the quiz already. I'm more interested in how do I get the answer?
You just add, since it starts off at 1, just add 3.
Okay. So
Go
what you
up
said is
3.
completely right, but I want to break it down. So Chris said, okay, since it starts at the 1, just add 3. But what are you talking about when you say it starts at the 1? What starts
The
at
y-
1?
the y-intercept.
The y-intercept. The y-intercept of which function is 1?
So, fx.
So okay. If anyone else wants to answer this, I'm totally open for it, but I'm only grilling you because I want it to make sense for everybody. When you say it
Oh,
starts at the 1, how do you know that?
uh, because since it only shows the 2 in
Mhm.
x part, and it says plus 3. Pretty much, we just have the base y-intercept at 1
Okay. Good.
because
Okay.
that is
That's
the
what I wanted. That's what I wanted to get you to say. So, what is this called? This function right here. We've talked about it. What is that guy called?
parent function.
That's the parent function. That's the parent function. And remember what we talked about. Every function in the world, you can get a function by starting at the parent function and doing something to the parent function. Because you can take the parent function and move it up, move it down, move it left, move it right, make it steeper, make it less steep, turn it around, flip it over. You can do a lot of different things to it. But when you start with the parent function, one of the most common things you're going to see is it might add something to the parent function or it might subtract from the parent function. What do we know about the parent function? What is the y-intercept of the parent function? What's the y-intercept of 2 to the power of x? Good, Daniela. The y-intercept is 1. You might just know that. You might have remembered it from last week. But if you didn't remember it, what's something you can always do to find the y-intercept?
Look at the graph.
Without a graph, just from this equation. Any equation in the world, what do you plug in order to figure out the y-intercept?
Oh, I guess 0.
0. Exactly. Anytime you have a function, if you plug in 0, you'll know the y-intercept. Well, because what is 2 to the power of 0?
Uno.
Is 1. So I know that the y-intercept of the parent function is 1. Okay. Well, my function is just the parent function plus 3. It's the parent function plus 3 because this part of it is the parent. So if the parent function has a y-intercept at 1, then my function, since I'm adding 3 to it, where's the y-intercept going to be?
4.
At 4. Because all I need to do is I'm just doing 1 plus 3 gives me 4. So I take a look at my graphs and I try to figure out, okay, which of these has a y-intercept at the 4? So I can zoom in a little bit and I can see that answer choice A passes through the y-axis at the 4. And that's all you have to do. That's the quick and easy way to do this problem. So I know that a lot of people struggle with this, so I'm going to give you guys a couple of examples. Ignore the graphs for a moment, but tell me, what is the y-intercept of the following functions? I'll put a couple up. Okay. So Let's just think about this, because remember what I said. The parent function is kind of like your base where you start, and that y-intercept of the parent function is 1. So looking at g of x, what would be the y-intercept of g of x?
-4.
Okay, how'd you get that?
I, -5, 1.
Someone else, because I've been talking a lot to Chris. Someone else explain, how do you find the y-intercept for g of x? Subtract 5 from 1. Exactly. We start at 1. 1 minus 5 is -4. Boom. What's the y-intercept for h of x?
Eight.
Good. 8. Because again, you start at 1, and this time I'm just adding 7. So I get 8. That's it. Now I made things a little bit more interesting, but m of x and d of x are pretty similar, because what would be the y-intercept of 3 to the power of x? Think about it. What would be the y-intercept of 3 to the power of x? Would it be the same as the parent function or different from the parent function? It's okay, I can just sit here silently. I'll wait. Good, Cassie. You got it. -8. -8. Guys, 3 to the power of x, let's just say that's my new function. I'll call it m of x. If I plug in a 0, I still get 1. So the y-intercept of 3 to the power of x is still 1. So I'm doing the same thing. 1 minus 9 is -8. What about d of x? What will the y-intercept be?
3.
3. Good. Okay. So always think about it that way. When you add a number at the end of it, you're just going to take that number and either add it to 1 or you subtract it from 1, depending on if it's plus or minus. And that's going to tell you the y-intercept. And once you know the y-intercept, it's going to be very easy to identify the correct graph. So do I have any questions on what I just did there? Anything at all? Okay. Moving along. Last one. This one has end behavior, which I know a lot of people get a little tripped up on. So I just want to review one thing. When I write this statement right here, x is going towards infinity. X is approaching infinity. Which side of the graph is this telling me to look at?
Right.
Right.
Good. This is saying, hey, Miss Lopez, look on the right side of the graph. That's all it's saying. It's just telling me where to look. Same thing in the other way. If x is approaching negative infinity, where do I look?
Left.
Yeah, to the left. That's all. So if you notice, on all 4 of these answer choices, that stays constant. They're not changing that at all, because that's not what changes. Which part of these 4 answer choices is the part that changes?
The fx.
The f of x, because that's talking about the function. So now we can take a look. Okay, so it's asking us to define the end behavior of stock B. Stock B. So which one is my stock B? Is stock B increasing or decreasing?
Increase.
Stock B, look carefully, where is it?
Decreasing.
Decreasing, it's this one right here, it's going down. Whoever has that stock is in trouble because that value is decreasing. So now I look on that graph, I look at that function, and I'm gonna look on the right side. So I'm looking right here on the right side. Where is the function going? Where is the stock going? Up, down, or to zero?
To 0.
To zero, good. So f of x is going towards zero. That's on the right side. When you go over to the left side, where is it going?
Increasing. Infinity.
Good. It's going up, it's increasing, so it's going to infinity. So on this side, it's going to infinity. So the function is going towards infinity. On the other side, my function is going towards zero. And that's how you read this type of notation. So this was answer choice B. That was my answer. So this is how you read it, okay? It's not hard to do. It's just something that's written a little bit differently than what you might, like it's not words. It's just algebra. It's just like function notation with numbers and symbols and stuff. So you have to make sure that you read it carefully and that you understand how to read it. So does anybody have any questions on how to read this? Anyone? Now this is stock A, or no, this was stock B. So now think about it for stock A, just to check your own understanding. I'll give you guys about 30 seconds to fill in the blanks for stock A, just to make sure you know how to do this.
Infinity. Positive.
Okay, so here's stock A. On the right side, Chris, say that again. On the right
Infinity.
side, it's going towards? Good.
Positive.
Good. To infinity and beyond. What about on the left side?
It's approaching zero.
It's approaching zero. It's going down. And so it's kind of like the complete opposite of stock B. Any final questions on how to read this, how to make sure you are, choosing the right option? Here's a good question. Is it -0 or just zero? It's going to be just
zero.
Yeah, just zero, because zero is zero no matter what. Infinity can go either way because it can go up or down. But zero is just talking about the x-axis. So the x-axis doesn't have a direction to it. It's just where it is. So either you're coming towards it from the top, you might be going down towards the x-axis, or you might be going up towards the x-axis. But either way, you're just trying to reach the x-axis. So it doesn't have to have a plus or a minus next to it.
Miss, I have a question.
Go ahead, Miriam.
What is -0?
That's kind of what I'm trying to say. Like -0 just isn't a thing. Like zero does not have neither a positive nor a negative to it. Because zero is just zero.
Okay, thank you.
You're welcome. Okay. So that was everything from the quiz. Now what I want to do, we have a little while left. We're not going to be able to spend all the time doing this, but that's okay. What I want to do is I'm going to send you all a link to a worksheet. That worksheet has 10 problems on it. What I want everybody to do for 15 minutes is, first of all, look through the worksheet, identify the problems that you would not be able to do by yourself. Okay, so look through each problem and try to think, can I do this or do I need a little help? For the ones that you need help with, send me those in the chat. So let's say, okay, Miss Lopez, I don't know how to do number 3, number 4, number 7, and number 9. Just let me know. Because what I'm going to do at the end is I'm going to go over the most popular answers that most people don't know how to do. So does that make sense? So you're going to take a look at the worksheet, find all the problems that you don't understand, and then use the remaining time to work on 1 or 2 problems that you do know how to do. Does anybody have any questions on what you're supposed to do once I send you the link? Okay, so give me 1 second. I'm going to send it in the chat. And I'll let you guys know when there's about 2 minutes remaining. We're just going to spend 15 minutes on this. We're not going to spend a whole lot of time because I want to make sure we have time to go over the most challenging questions. Where is my, oh, here it is. Okay. Okay, here we go. Sorry guys, it's just taking a minute to load. Oh, it's taking a really long time to load. There we go. Okay. All right, there it is. So go ahead, click on the link, look at every problem, and let me know which ones are the hardest for you. And then use the remaining time to do 1 or 2 questions that you do feel good about. Okay, I'm going to set a timer right now, 15 minutes. All right, there's a little bit less than 5 minutes remaining. So in these last 5 minutes, please go ahead and start sending me which ones you want me to go over, and then I will pick the most popular answers. It could be one, it could be two, it could be all 10. Just tell me which ones you would like me to go over. All right, just about a minute and a half remaining. Again, let me know which questions you want me to go over. Right now, put it in the chat privately. Let me know which ones you want me to go over, and then I'll probably get to like 2 or 3 of them. But whatever we don't finish today, I'll try to get to it later this week. All right, 20 seconds remaining. Now's your last chance to tell me which question or questions. It could be many questions. Just let me know in the chat. I'm keeping track of everybody's answers and I'm trying to see which one is the most popular. Let me know now or forever hold your peace. Now's your chance. All right. That's time. Okay. So the most popular one by far was question number 4, problem number 4. So I'm going to start with that one. And then another popular one was number 3 and number 9. So we'll see if we get to those as well. Starting with number 4 though. Yeah, a lot of people had issues with this one. So with this problem, there's a lot of different approaches to it, but here's what we're going to do first. I have a graph of this function. The graph tells me a lot of information. Even if I don't really do any math, I know at least 2 things just from looking at the graph. First of all, is this a growth function or is it a decay function?
Growth.
Good. How do I know that something is growing? Remember, you always look from left to right. So in this case, even though these dots aren't connected, even though they're not connected, it's still going in that direction, it's still growing. So I know that it's growth. Okay? And since it's growth, since I'm talking about growth, what is the number in the parentheses going to be? Is it going to be a number greater than 1 or is it going to be a number less than 1?
Greater than 1.
Greater than 1. So the number in the parentheses, the growth rate, should be greater than 1. So which answer choice can I eliminate right off the bat?
B.
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 Good. Good, good. Okay.
Another way you can eliminate answer choices is by looking at the y-intercept.
Good. That's exactly what I was going to say. The next thing you can look at is the y-intercept. So yeah, okay, it's kind of in the middle, but what's right in between 1 and 2?
1.5.
1.5, yeah. So I know that my y-intercept is 1.5. Well, that means that the number outside of the parentheses should be 1.5 because I remember that for any function, it's always a times b to the power of x. And a, what does a always represent? For exponential functions, what does it always represent? Good, the y-intercept. So I'm looking for that number to be 1.5 and for the other number to be greater than 1, and only one of those answer choices fits the category. That's going to be A. D is definitely out because the y-intercept for D would have to be somewhere down here. 0.25 is under the 1. So that one's definitely out. And then if you were stuck, which is totally understandable, if you weren't sure between A or C, something that you could do is plug in a number. So for example, look at all of these dots. Does anybody see which one's kind of like the most perfect of those dots, of those points?
The y-intercept would
So
and
the most perfect though, like I'm trying to see which one is like almost exactly on a number.
The second one.
3.
Okay, so those are 2 good ones. So the second one is good. The second one's a little bit under, but both of them are pretty good candidates. So 3, 3 and 1, 2, right? Well, you can plug those numbers into answer choice A and answer choice C and see which one gives you the right answer. So like if I plug in a 3, I'll do it really quickly. 1.5 times 1.25 to the power of 3. And I can do it here as well. 1.25 times 1.5 to the power of 3. If you do it on your calculator, I already know the answers because I did it before. But once you actually work it out on your calculator, this one gives you like 2.9 and this one gives you like 4.2 or something like that. So I know that it should be about 3, 3. I should get 3. So that one's the only one that gives me the right response. This was too high. So that's one way to just like check your answer is you can always plug in an input value and see if you get the correct output value that matches with the graph. So any questions on this one? Quick questions. I know the bell's about to ring. I'm going to try to get one more. So another one of the popular requests was number 9. So I'll go to that one real quick. And number 9 is a really good problem because it covers a lot of information. So the value of a painting recently sold at an auction is expected to increase in value over time. The function v of t equals 12,000 times 1.15 to the power of t represents the value of the painting at time t, where t is the measure in years since the painting was sold at the auction. Which of the following provide a correct interpretation of the function? Select 2 that apply. So we know there's only 2 answer choices that are correct. Well, let's break it down. We know, we went over this earlier. Each of these numbers represents a different thing. What does the 12,000 represent?
Y-intercept.
The y-intercept. Good. And what does, in the real world, what does the y-intercept always represent?
The starting.
Good. Starting amount. So the painting you started at $12,000. The painting started at $12,000. So here we go. Let's look. Oh, answer choice E. The painting's value was $12,000 at the time that it was sold. Done. Now, what does the 1.15 represent?
The growth.
The growth rate. Good. Okay. That's the growth rate. So it does not represent time. It does not represent value. It's just the rate at which it is growing. But now let's be very careful, because what if that's the rate, what's the percentage?
15. 0.15.
0.
15%.
Good. It's 0.15 as a decimal. So as a percentage, that's going to be 15%, because it's the number that you add to your 1. So there it is. I see it in answer choice C. Everything else is just trying to trip you up. All those other answer choices are just trying to give you the wrong impression. So we got to be very careful with those. So any questions on this one?
Nope.
Okay. So at this time, I know that the bell already rang because I see everybody's leaving me. So tomorrow, like I said, we're learning one last new thing tomorrow. And then from then on, Wednesday, Thursday, Friday, and Monday, we are reviewing. Now, and I'm going to say this now. I know that class doesn't end until 3:50, so technically we've got time. I'm pretty disappointed in this class. I've noticed a trend in the last month or so, and it's getting to a point where I know I got to do something about it, but I am pretty disappointed by the level of participation. And by that, I mean the lack of participation. I know I've got a solid group of like 5 students who I always see participating either out loud or in the chat, but that's only 5 students and there's like 30 of you guys in this class. So going forward, I want y'all to start thinking about the fact that in order to succeed in this class, the more you participate, the better you're going to do. And I need everybody to step that up, because I don't know what's going on. I'm loving these conversations I'm having with Chris and Cassie and Marion and Daniela and Dejuan. And that's about it. And nobody else ever wants to speak up. And that's a big issue, because as a teacher, it's hard for me to teach when I don't really know how the rest of the class is feeling. And I'm not saying anything bad about those who do participate. I love that you guys do so, and I want you to continue doing so. I'm not telling you to stop. I just want everybody else to get to that point as well and try to feel more comfortable. And I always say, like, you can participate in the chat, you can do it privately. I don't care. That's fine. And I'm not going to say your name out loud if you don't want me to share what you said. But like, I just need you guys to step it up a little bit, because I'm tired of having all these blank screens in front of me who don't really participate. Okay. So that's just something to keep in mind. And we didn't get to all the other questions, but I will make sure they come back later this week when we continue reviewing. So probably on Friday, you'll see those questions come back and we'll go over them together. All right. So
you're not going to go over number 5?
No, not right now. I'll do that on Friday. Okay, I'll get to it on Friday. If you want to know the answer, for this one, it would have been answer choice D.
I feel I was wrong. Anyway, bye.
Okay. All right. Bye, everybody.
Bye.
Bye, Miss.
See you tomorrow.
See you tomorrow.